Hello friends and welcome at my channel. Today I would like to investigate the function f of x equals to 8 divided over x squared minus 4. We go once again through all the steps. First of all, the domain, and as you can see, x is not allowed to be neither 2 nor minus 2. Alright, number 2. What about the symmetry? Do we have a symmetry here? Yes, we do. Symmetry considering the y-axis because f of minus x would be equal to 8 divided over minus x squared minus 4. This is 8 divided over x squared minus 4, and that's the same as f of x. So check. We are symmetric, which means I only have to understand what's happening on one hand side, considering the y-axis, and the other hand side is immediately given. Number 3. Well, here we have to deal with infinity, of course. So limits x towards infinity. Obviously, the denominator is winning clearly, so it's going to be 0. And because of the symmetry, I also have plus minus in both cases 0. That's it. But what's happening around 2 and minus 2? So let's say we're approaching 2 from the right hand side, as you can see. So we're slightly bigger than 2, like 2.1 or something. If we square it, we're slightly bigger than 4, so our denominator is very small positive number. Dividing 8 by a very small positive number gives us plus infinity. Because of the symmetry, so we're slightly behind 2, let me put it here. So this is 2 and this is minus 2. We're further than 2, we're coming from this side. This is the same result as we're going to have here. So limit x towards minus 2 from the left-hand side must give me, because of the symmetry, once again, the same result. All right, what's happening if we are approaching 2 from the left-hand side? So we are coming from this side. That means we are having a very small negative number, um, well, close to 0, but negative, and we're dividing 8 by a negative number close to 0, which means we're going to get minus infinity. And this is the same result that we're going to get once again through the symmetry if we're approaching it from the right hand side from f of x. All right, let's move on. Number 4, 0 points. Well, we have none again because the numerator is never equal to 0. First derivative. I'm rewriting 8 divided over x squared minus 4 as 8x squared minus 4 to the power of minus 1. So that means minus 1 is coming down. We're having x squared minus 4 to the power of minus 2 times 2x, which is an inner derivative. So basically we're getting minus 16x divided over x squared minus 4 squared. Is it 0 somewhere? Sure it is. We're having x equal to 0. And what about the second derivative? Well, for these reasons, now we're going to do the quotient rule. So I'm keeping minus 16 outside of the business. We're having 1 times x squared minus 4 squared, and then minus x times 2 times x squared minus 4 to the power of 1 times 2x divided over x squared minus 4 to the power of 4. So what's happening here? We're having minus 16. I'm taking x squared minus 4 outside of the parentheses. As you remember from the previous exercises, it's always the case in these cases, in these situations, because we want to cancel, we want to simplify, and we want to cancel as much as we can. So x squared minus 4 is remaining. The whole parentheses with x squared minus 4 are gone. And what we're having is, that's all right. I'm trying to avoid any kind of mistakes, which I'm normally doing. So minus 4 x squared seems to be all right. Yeah, I'm closing the parentheses and I'm going to have x squared minus 4. We take it cubed and then we have x squared minus 4, one more remaining, so we're canceling those two. And the result would be minus 16 still. And as you can see, we have minus, okay, let me write it, minus 4 minus 3x squared in the parentheses divided over x squared minus 4 cubed. And we're kicking minus out. And we're multiplying times 16 as well. So we are going to have 64 plus 48 x squared divided over x squared minus 4 cubed. I think I have no mistakes here. Let me check. Seems to be all right. Okay, I think so. So what about the second derivative at 0? The second derivative at 0 obviously is 64 in the numerator and minus 64 in the denominator, so it is equal to minus 1. It's negative, so we have a max. Have a max at 0, and if I'm putting for x 0 here, I'm gonna get minus 2. So at 0 minus 2 we get a max. All right. Question number 6. We are handling the second derivative, which is here, 64 plus 48x squared divided over x squared minus 4 cubed. X squared minus 4 cubed. This is the second derivative, and as you can see, it's never 0 because the numerator is always greater than 0, right? So no points of inflection. Number 7, we plot the graph. Let's see. No 0 points, that's sad. Well, I think maybe I should go a bit further. Right here, okay. So we have at 0 minus 2, the max. We are turn apart at minus 2 and 2. Looks like that. We have at 0 minus 2 just one max. We are going to minus infinity in close to 2 from right hand side and from the left hand side to minus 2, and we are symmetric. So if you are in such a situation and if you don't have enough information, one of the great reasons to help yourself is just to plug in some points if you need. Well, imagine I would have done it, so I put 1, I put 1.5, I put 0.5 and whatever. So I'll figure out this is a kind of parabola living inside this hyperbola. It's symmetric. And next to 2 from the right hand side, we're going to minus infinity, and we have no points of inflection, so we're never changing our curvature. Once again, if you need, like, plug in 4 or something, and you will see that the graph looks like that. And because of the symmetry, it must be the same here. So this is what's happening. This is the graph. And there we go. Thanks for watching. See you guys in the next video.